So now we're on to target 5. Target 5 is supposed to correct the problem that was in target 4 where the buffer overflow could modify that variable. Let's see how that was done. We'll look at check password and just start going down through it like we usually do. This is where it's setting up the stack. This is the top of the loop where it's, I guess, counting how many times you've entered a wrong password. It's prompting you here. Here's where it presents the other prompt, and then right below that is where both of the prompts end up, which is where it validates the password. So we see it calls the validate password routine, and then it tests the return result, which is an EAX, and if it's equal to 0, it jumps down to 4011CF. If it's not equal to 0, which means it returned a positive value, and that means the password is validated, it puts a 1 in EAX and then jumps to 4011DE, which we can see is just a return. So there's no variable now keeping track of whether or not you entered a correct password. Instead, it just immediately returns a 1 if you've entered the valid password. So we can't use a buffer overflow to fake out the validate password, but maybe we can use a buffer overflow a different way. So let's go back to the top of check password and set a breakpoint here, and then continue. So now we're at that point. We've just called check password, and let's look at the stack. So you can see here at the top of the stack is 221140, and hopefully by now you recognize this as possibly a pointer into somewhere in the code, because these are bytes in reverse order. So this is the address 401122, and if we go back here and look at 401122, hitting the wrong key, 401122 is this test right after the call to check password. So the idea here is when the check password returns, it's going to pull this address off the stack and jump to it, which is then here. So this is what happens right after the call to check password. So what if instead of this call to check password, what if instead of returning here to 401122, it returned to right here, 40112B, where we're calling open lock. So what if we could just bypass the test, testing whether or not check password returned a positive value, and just say open the lock no matter what? Well, if we could somehow change this address, the 401122, to be 40112B, then when check password returned, it would return straight to this line, and then it would open the lock. So why don't we do this? Why don't we go down here and set a breakpoint, so we'll see if it hits open lock, and then let's continue on looking at check password. Let's look at what the stack looks like right before it calls validate password. So this is after we've entered data at the prompt. And what I'm going to do is I'm going to put in some hex data. I'm just going to put in 1122 1122334455 and hit enter. So we saw this the last time when we were overriding the variable in memory, but now we have something else we want to do. The place where we're entering data is at D010 here. So you can see the 1122334455 that I entered in hex. And what we want to do is overwrite this value way down here at D038. And so there are 1, 2, 3, 4, 5 rows of 8 bytes. So that's 40 bytes. So we have to enter in 40 bytes at the input so that the next byte we enter will be this 22. And I suspect that it probably null terminates the password that we enter. So we probably want to go ahead and enter 2B1140 here just in case it tacks on a 0, because otherwise if we just put 2b here, we might end up with 2b0040, and that wouldn't work, and we then have to do it again. So I'm going to let this continue, and it's going to tell me that it was an invalid password. So now what I'm going to do is I'm going to enter 40 characters. And in order for me to keep track of this mentally, I'm going to enter hex characters in sequence, starting at 20, 21, 22, 23, and so on, up through 29, and then do the same with 30, and then 40, and then 50. And now this should be 40 characters if I got all the ones in sequence. So now we want this to be 2B1140. And I'll hit enter, and it should hit that breakpoint. And let's look at the stack now. So the stack, it went 20 all the way up here to 59, and then look, we have 2B1140. So hopefully when this routine returns, look, it popped right to the open lock, and if I hit continue again, we've unlocked it. So this is a buffer overflow. This particular attack is called return-oriented programming, because what you're doing is you're changing the stack in order to have it return to a particular place. And there are times where you can use chains of these so that you can return to one place and then have the stack such that when that returns, it'll return to another place, and so forth, and you can chain these together. So that's it for Target 5. It was probably maybe easier than Target 4 as far as analysis, but it's also probably a more common way to attack things than Target 4. So we have one more, Target 6. Let's see what that one will be like.